Okay, so hello everyone. I am Bhaskar Banerjee and I welcome you all to this week's code walkthrough session, week 5. So in this week we will learn about a concept called generics and we will see what generic programming means. But before diving into the code walkthrough, let us have a brief recap of what we are going to, the theory part and what we are going to achieve by learning the contents of this week. So basically you see that now in this week we will try to achieve something which we call structural polymorphism. Now what is structural polymorphism? We have already been acquainted with the term polymorphism, but that aspect of polymorphism was more a dynamic approach, so we call it dynamic polymorphism. Now what was that polymorphism? So let's say we have a superclass and or we have an interface, either if you consider it in terms of superclass also, then also it is fine, or in case of interface. But anyway, so let's say we have a super type reference variable, and in that reference variable we can actually store any if it is a class, super class, then we can store any subclass instant, or if it is an interface, we can store any class which implements that interface, right? That means which implements all the abstract methods of that interface. We can store the instance of such classes into the interface's reference variable. So whatever it is, either it is class or interface, so basically we are able to store multiple instances of different classes in the same reference variable. And because of this, when in the runtime, when we actually call a method which has been overridden by the concrete classes, so by using the same reference variable, then according to the instance which is there inside that reference variable, at runtime it will be resolved and the corresponding version of the function will be called. So this is what we call polymorphism. So basically you are using one reference variable to which is able to store multiple class instant to do one task in different implementation. So that this is a that's why we call it polymorphism. So because you're using multiple let's say forms in one thing. But here what we will try to see is what we call structural polymorphism. And the idea of structural polymorphism is rather than inheritance or any class interface relationship, what we want is we want a more general structural polymorphism, which basically means that we will be able to apply multiple data type operation on functions or on classes that we define. So we define it for a single type, and we define a generic class or a generic method which will be able to work with different data types. So this is what we call structural polymorphism, because here the multiple polymorphs, the word polymorph means multiple forms. So here you are able to do the polymorphism in a more structural manner rather than in a dynamic manner. Here it is more structural manner because you are defining a class or defining a method which is now once defined is able to work with different data types. So you don't have to change the data types of the let's say the data types of the specific elements within the class or within the method, but you can now work with different data types on the same class or method implementation. So this is the idea of polymorphism in this case is kind of more towards the structural nature of this utility. So that's why we call it structural polymorphism. So okay, so the base part of it is we want to basically create methods and classes which will be able to work with different data types, right? Okay, so now once we have discussed that, so how can we actually kind of try to apply this thing with our previous knowledge? Whatever we know, let us try to apply that with apply this concept with our previous acquired knowledge. So one useful tool is our object class. So you know that the object type is kind of a class which is a super class of any Java class type, and that's why it can serve as a reference variable to instance of any class in Java, right? Any user defined class as well as any predefined class as well. So now if that is so, can we just take the reference of object type and use it as a structural polymorphic structure structural polymorphic reference? Why? Because it will be able to store all kind of instance, so there will be no so we want to work with different data types on the same definition of a method or a class. So if we define everything as object within the class or within the method, then it should work properly, because any kind of data type we pass into the method while calling the method, or we pass into the class while making an object of that class, right? If both the class and the methods are made with only object type references, then they will accept all kind of data types, class data types. So that is one solution. Yeah, it works, and that has been discussed in this if you see in the lecture 1. So this is what we have discussed, that we are making everything to be object type. So here the return type is object, here the parameter type is object. So see, everything is made an object type. All the values are made to be an object type. So here also I am defining an object type data. So the data parameters, return value, everything is made object type. But as we have seen in the lecture, sir has taught us that this will have problems. What are the problems? So basically the first problem is we cannot enforce homogeneity. Now the thing is, since object references can accept all kind of class instances, this also at the same time provides us difficulty. Along with the features that it provides us, it also makes us fall into a difficult situation, and that is basically we will run into different kind of exception, and predominantly the class cast exception that will occur at runtime. Okay, so why would that happen? Because since an object type without any check can accept any instance, right? So if you store by mistake or not even by mistake, let's say you create an object type array, and inside that object type array you are storing multiple different instances of different class. But at runtime, when you are using that array, let's say, I mean, any function is using that array, it might so happen that you do not know which position what element was stored, and you are kind of now trying to fetch those elements from the object array to do some work on them. And if you are not properly aware of which particular class element is there, instance is there, and which is not possible to know because it will only be resolved at runtime. The instance type is resolved at runtime. The reference type is known at compile time. So let's don't confuse in that part. So we cannot know the instance type until we go to runtime. And if at runtime there is an issue with different instance type that you have stored in another instance's place, so you will get into class cast exception. So what I mean is any object array can actually store in every element of that array, in every cell of that array we can store any kind of instances without any check. So this without any check property, that is accepting all kind of instances, creates us some difficulties, and mostly this will lead to, if we are not very careful and if we are not sure of every type of instance in each cell of such an object array, then we will not be able to do the explicit typecasting when we want to retrieve those objects from the array and let's say call a method of the appropriate class. Right, so we cannot do that. But if you know that every position which class is there, then there is no dynamism in this program. I mean, it's kind of a static hard-coded program. And if you do not know that what is there at which instance is there in which cell of the object array, then you cannot do typecasting, right? And if you cannot do typecasting from object to that particular class type, then you cannot call any method of that particular instance, right? So and in this process, if you make a mistake, like you basically do a typecasting of some other class on an instance of some different class, even if it is a super and sub relationship, then also the typecasting in case of instances will be wrong, right? In reference, it is not an issue. So you will run into class cast exception. So that's why, first of all, it does not guarantee homogeneity. That is, we cannot have a homogeneous known behavior. Along with that, it will also increase the risk of exception that might occur at runtime. Now, what are exceptions that we have not yet learned? So exceptions as of now, just think of it as some errors that will occur at runtime. Right. So we know compile time error, but we do not know what are runtime errors. So runtime errors are basically which we call exceptions. So consider it a simple runtime error. So basically you could run the program, in the compile time you wrote the code, no error was shown, but once you run the program, then you see that there are some errors and the code is not running. So those kind of errors are called exceptions, right? Fine. And what is much more important than both these 2 points are, let's say even if you are careful about everything, and you do the typecasting and all those stuff properly, and let's say you are not quite, you do not want the homogeneity property to be satisfied that much. So all these things are fine, but what the second point in this page says that another problem with the using of object type to achieve structural polymorphism is it cannot enforce selective subtype supertype behavior. Now what do we mean by selective subtype and supertype behavior? So let's say, as I said, that any object type will object reference will take any kind of instance variable, right? But let's say now I want such a method. Let's say I have a comparable method, right? So let's just kind of let's say I want some there is some class. Let's say class compare, and then let's say I want to have a method in this compare class, which is public void compare to method. Okay, and this compare to method, what it is basically supposed to do is it will take 2 parameters and compare between them, the simple comparison. And now let's say in this class we have a simple comparison based utility, and we want to compare stuffs, and I want this class to be able to work with different data types. Now let us try to think what we can put in this compare to method parameter. So if I define it as object, let's say I take object O1 comma object O2. Let's say I do that, and then I do some comparison task within the method. Now the issue with this is, can I compare between 2 unrelated types? So let's say I want to compare between Scorpio and Xylo, or let's say I want to compare, so basically speaking, let's in terms of classes, I have a car class and I have some subclasses from that. Let's say a Scorpio, right? And then let's say I can have a Thar or whatever. I can have a Gurkha class. I can have SUV classes. I can have multiple classes inheriting from the car class, right? With specialization, respective specialization, depending upon which subclass it is. And another way, on another side, I have a helicopter class, right? And under that helicopter class, let's say I have different helicopters, specialized helicopters. Let's say I have Apache war helicopter. Let's say I have Mi-26. Let's say I have a Chinook. Let's say I have Pawanhans helicopter. So different helicopters that are there. But and I want to do a comparison between them. So I can compare between cars, or I can compare among the helicopters. But can I compare between, let's say, Scorpio and a Mi-26? No, right? I cannot compare between a helicopter and a car. So that's where we run into trouble. If we keep this compare to parameters to be both object type, then they will also accept, I mean, since it will accept any two instance, it will also accept a car, and another one will accept, another object 2 will accept, let's say, helicopter or something else. So, and then it will start working on it. Right, and then we, according to the implementation of the compare to method, we are most probably, most probably will run into some error because we are trying to compare completely two different things. So this object type use of object type in such a scenario, it does not restrict us from using unrelated class type comparisons. Right. So whenever we want to, we want dynamism, we want multiple classes, we want structural polymorphism, but that structural polymorphism should be meaningful. That is, we should be able to use different data types, but those different data types, there are also relations between them. I don't want any unrelated types to be compared or to be worked upon with. So in that case, our object reference variable will not be able to provide us with this feature. Right. So we need to make something which will enforce us that, okay, you have a generic behavior, but I can work with multiple different data types, but then also within those data types also there are groups, and within those groups only I will work, something like that. So as we see that these are the disadvantages, and we cannot implement the concept that we want to have, the utility that we want to have with simple object type reference. So this is where the generics in Java were introduced. So now let's come into the code, and now we will see what are generics. So as you can see in the lecture slides, sir has okay, so this is kind of done. The next lecture, yeah. So here we have seen the first use of generic, and which is basically this T, and in the lecture it is discussed. So what we are trying to do in our code, in the today's code walkthrough session, we will try to change our already implemented linked list class, right? I think the name was different in this slide. The name linked list is used, so accordingly I have changed the name of linked list class over here. But I think in the previous week's code walkthrough session, we used the class name as I think linear list or something like that. But basically the thing was same. We implemented a linked list, and the only thing that I've changed over here is the linked list class name. Everything else is mostly 90% of the things are same. We will only change a few things in the class definition from our previous code so as to make it into a generic type linked list. So I mean, if you guys remember that the previous linked list was only working with integer data types, right? Because our data field within the node was an int type. So if I now just directly go and show you that now it is a t type, right? So we have changed that data field type. So now let's come and see how it works. So that is the only change. We have a iterable interface which we use for iterator, so that also is same. Nothing else, there is no difference. So the way to define, as we said, that there are two ways to do generic work in Java. The first is you can create a generic method, and second is you can create a generic class. Now this is a generic class, and this is the format of defining it. So we have a angular brackets t, or you can write any variable or anything over here. So preferably t, s, and q. These kind of letters are these three letters most preferably are used to symbolize a generic type. But you can use anything according to syntax. So here you have to put a t. This is the definition, which means that this linked list class is a generic type, and the user, here the user means the programmer who is writing the main. So that programmer will mention while creating an object of this linked list class that what type this t should correspond to. Is it a string type, any object type, any particular user defined class type, or some whatever type you want to give. During the instantiation of the linked list class, we will have to provide that detail. Anyways, so now we have this. Now since this t is there, I can now use this t variable, not variable, basically this t placeholder in any place where I want that type, right? In the main method, when we instantiate, we will provide the type, right? Which type we want this linked list to work with. So that type if I want to refer to that type within the linked list class's body, so I can do that by using this t as a symbol, as a type, data type. So now accordingly, I think the name in the previous question was, previous code was head. We have changed that to first according to the definition used in this week in the slides. So here it is first, so we have changed it. Otherwise everything, the logic is same. So we are having a constructor which is doing the normal initialization. So this is something new which was not there in the previous code. So this is, we have a public method head, and you see the return type is t. So this T type we can use, just think of it as any data type which will be understandable at the runtime. So since it is a data type, you can just put it in all the places. So T can be put in all the places where you can usually put any data type. So data types can be put in parameter part. Data types can be not can be. Data types are used before defining a parameter in the method. Data types are used before defining a variable within the method or within the class. Data types are used as return value type within in a method, right? So accordingly, in all these three places, you can use the T type. So here T is a return type. And the head function is what it is doing is, see, the implementation of head function is not very properly talked about in the slides as well. So but kind of it says that you are returning the value of T type in the head method, and since the term is head, what we thought is, let's make it as the return when we call the head method, it will basically return the head pointer, current head pointers object. So whichever node the head pointer is pointing to, which is basically the start of the linked list. So we will return the data present inside that node, right? So the data will be what? In the previous example, the data was integer type. Now in this example, the data will be generic type. So that's why it is defined with the T type. As we saw that inside the node class, we have the data field defined as T data type. So that means that generic data type value, whatever is there inside the first node of the linked list, which is being pointed by the first pointer, I mean this head pointer. So in this first pointer, in this case, the first reference variable, that will be returned by the head function call, right? And once that value is being returned, right? Then it is what we will do is we will move the head pointer to the next element in the linked list. So it is as if you are taking, if you call the head method, you are taking out the first element from the linked list and returning the data inside that node to the main method, and or from wherever it is called, basically you are returning there. And then once you have returned it, so you have just kind of popped it out, you have outputted it, and then you are moving to the next node in the linked list. So that is what we are trying to do in this head method, and this is the implementation of that. So we have a return val variable, and inside that variable we are basically putting the first dot data. Data is the node class's data field, as we already know. So first dot data, and after we put the data into the return val temporary variable, we can just simply change the head pointer to the next field, so it goes to the next node in the linked list. And then since we have now decreased, I mean, since we are kind of trying to move the head pointer to the next field, the next node in the linked list, which essentially means we will kind of lose the first node, and we are trying to put it away. We outputted it, and now we want to just move it out of the linked list. So that's why we do one size minus minus, so that our size remain consistent with the current structure of the linked list. So and then we finally, at the end of the work, we will return the value which we have taken out from the first node of the linked list. So this kind of behavior is also called first in first out behavior. So basically first in first out means whichever data item got first into the linked list will also be moving out of the linked list at first. So since the head pointer is the first element which has been inserted into the linked list, and since when we call head, it is moving out of the linked list at first, so therefore it is called first in to the linked list and first out of the linked list. So this is called FIFO strategy, and we will learn about this FIFO and different strategies in your programming data structures and algorithm classes, but also in Java we will learn it in more detail once we move to the collections in the further weeks. But basically this is the idea of it. So whichever data came in first, it will move out first, and since the head pointer stores the data of the starting node in the linked list, so that is evidently the first one which came in first, and that's why it will be the one which is moving out of the linked list at first. So yeah, we have implemented this method, but now let's move to the next method, which is the insert method. The insert method, I think in the previous code was just a different name. It was under a different name called append, I think. Yeah, and here we are using the name insert according to the slides. Yeah, so this is insert. Okay. Now here also we have a parameter new data, because we want to insert a new class or generic type, right? Any type of object into the linked list. So since last time it was an object type, remember, because we were trying to put an integer object, and then we were doing a integer type conversion over here, and then we are passing it into the node parameters as an object type. So here in place of new data, which is now a generic type T, in the previous code it was an object type. So yeah, so that we are not doing now, because we have this generic behavior where we can pass any kind of reference object instance. So we will use this. Okay, so yeah, we are basically creating a node instance by using the node constructor, which is taking a generic type object new data, and then it will just put it into the data field of the node n, that is the n node which is created, node instance, and that first is equal to then n. Everything else is same. This is basically the same code, only thing is we change this t field, and everything else is just same. Now yeah, so here you see the node class t, it is the constructor of the node class is basically a generic type, and previously it was object type. Object 2 was there. Everything else over here is again same. So one thing I missed. Yeah, this insert definition, there is a difference from the slides, right? This T is not there in the insert, because this T is basically, sir has thought that this T is basically this is something that you should be very careful about. I will come to this discussion a little later now, but this is something which is wrong, and sir has taught us that this T shouldn't be there. If it is there, then it will create trouble. For trouble, we will also visit that, but let's just move on to the next part of the code at first, which is basically your iterable interface iterator. There is no such changes in it other than this. Again, the return type is t. The previous time the return type was object type. Now since we are returning the data within the node of the linked list, so we will basically, the data is basically of type generic type, right? So since we will return the data by get next, so that data, so the return value of get next is bound to be a the generic type, corresponding generic type. Okay, so you have this t type. Okay, so if we move further, this ticket and data class will come later. Let's revisit this insert method over here now. So as we saw that if I put a t over here, let's say, right, if I have a kind of a t over here, okay, then what might happen? Oh wait, sorry. Please be careful of these kind of simple mistakes, because yeah, if you put it after void, then essentially you kind of mean, I mean, just the thing before the function name is the return type. So if you put t over there, that would mean it returns the t type, which is not the case. So in the definition of a generic method, we define, so this is what is generic method. So kind of, now in this example, as we have already told, that we will discuss why this t shouldn't be there. I mean, the t is in such a place in this example which is troublesome, but we will see later also, just a little bit after this, we will learn that how to define a generic method. By the way, this is the general syntax of defining a generic method. We saw that we discussed that we can have two types of generic behavior. The first is your class generic, and then is the method generic method and generic classes. Now generic classes we have seen, but generic method is something like this. So after the public or private or whatever type you are mentioning, after that you write the T or Q or whatever, basically your generic symbol, and then you with the return move on with the function definition declaration, which is your return type, function name, parameter list, all those things. And this means essentially I don't need a class to have a generic method. I mean, class means I don't need a generic class to have a generic method. A generic method in itself can serve as a generic method, and it can work with multiple data types. So basically, whenever you call that generic method, whatever parameter you passed within that generic method, the Java compiler will automatically detect the type of the parameter which has been passed into the generic method, and it will instantiate the T symbol with the corresponding type. But so this is the thing, that if you are working with a generic method, you don't need a, I mean, you don't have to have a generic class, and in which only you can, there is no rule that you must have a generic method within a generic class. No, right? These are two independent things. But let's say you have a generic method inside a generic class, which is particularly in this case, which has been done. If that is the case, and if the name used are same, so let's say in case of T, if I would have used here something else, then this wouldn't have mattered a lot. But since the same name is used, now this is troublesome. Why? Because this t, the local t means which is the nearest one to insert method. Since now we are talking within the body of the insert method, the local t is this t, correct? So this t will overshadow the linked list t over here, right? Will overshadow. This doesn't mean both of them are same. Both of them are different. Both of them are different symbols, right? Although it is the same name t, but it is different symbol because it is within this local scope, and but the name is same. So what will happen is this insert t will accept data which is not even corresponding to this t. So these two t's are independent. So here, let's say this link, we create a linked list of, let's say, string type, okay, and if I pass let's say a capital integer, we discussed that you have for every integer or float we have some classes which was starting with capital integer. In our previous code we saw that, which we call wrapper classes, and we said that we will learn that very shortly. So in this week we will learn. So basically, let us consider that if you want to have a class representation of integer type, so you call it that capital integer, which is integer wrapper class. So let's take that into consideration in this example. So let's say I have a class of linked list of string type, and then I call the insert method with a integer type data within the insert call. As I told you that the compiler will automatically detect the type of the parameter, and depending upon the type of the parameter, it will just set the value of this t accordingly, right? So if I put an integer type within this insert call, right, integer type, so this t will be set to integer type, but the class was defined with string type. Now this is a trouble, right? So all of this will work, and the new data will be created. I mean, we are passing it into the constructor, but within the node class, we are using this t. Now this constructor will correspond to an integer value being passed into the data, but here actually the private t, here the t corresponds to the class t, right? Because here we do not have a local t concept. Like here we had this local t defined for this method definition, but here there is no local t. So here the t of data means this linked list class t, correct? So essentially, if I have created a string linked list, so this t corresponds to a string data type. So, but according to the insert method, this t corresponds to an integer type, because I have called the insert method using an integer type parameter, and therefore this node will pass an integer type into the new data. and therefore this node also, I mean this constructor will try to allocate an integer type into the data field, and this data field was initially defined t, which is your string type. So there will be a data type mismatch and an exception will be launched, right? So these are the problems. So therefore this local t will overshadow the outer t, and that's why we have to be careful while using generic method inside generic classes. Fine. So that's why you will delete it, but generic methods are quite a good tool, and sometimes it is very much required. We will see such a case very shortly. Okay, so other than that, there is not much to discuss. Now, as we can see in the slides, sir has implemented these two classes. Yeah, so sir has implemented these two classes, not implemented, instantiated these two classes by using a ticket type and a date type. So accordingly, we have created a simple, kind of a normal ticket and a date class, just to show you that this linked list can store different data types, user-defined data types, as well as some other predefined data types as well, to store different values within the nodes of this linked list. So we will store two object types, which is ticket and date, which are basically custom-defined classes. We have some random members and member functions over here. So what we are doing over here is we are creating a first linked list of ticket list and date list, right? This is the format. This is the format basically to create a generic class object. So you have to provide the class name, so which is linked list in this case, followed by you have to provide the type. So which type of data you want to store within that generic class. So it can be a string, integer, float, whatever, or some custom type, like here in this case it is ticket. So you store that, then followed by you put a name of the object, the reference variable, and then like new, again class name. Only difference is over here again you have to mention the type which you want the data to be, and yeah, then constructor call. So this is the format, and yeah, and then we are basically creating two objects in line number 113 to 116. We are creating two objects each for the two classes that we created, ticket and date, and then we are kind of trying to insert them by calling the insert function on date list and ticket list, these two lists, to store different types of by using the same class code, we are able to store different data types of custom classes object in this code example. Fine. So then we will have two iterators just to show that we can work. These iterable objects to get iterator, we are taking two iterators to traverse on the linked list, just like previous code example, and we can then call this print list method to basically print the values of the linked list by traversing the linked list using these iterators. So this method we will come to discussion again. This is where this method with generic type becomes handy, and this is a useful case where we basically use generic type methods, right? In this case, so we'll come to that discussion. Yeah, so basically in lecture 2 we have seen that how we can basically simply create a generic type linked list and put two different types of customly created class objects within that list, and then we can operate upon that. Yeah. Fine. Let's move to the next lecture, which is our third lecture. So this is about your Java generics and subtyping. Now, as we just said a little bit earlier, that this point that cannot enforce selective subtype supertype behavior, and I have given the example of comparing between helicopters and cars, that although I have a superclass, two superclasses, car and helicopter, and car has some respective subclasses, helicopter has some respective subclasses, and I want to compare between the subclasses of car, and I want to, let's say, between the car and one of the subclasses of car, then how much Scorpio is better than an average normal car. So let's say how much Scorpio, the class objects of the instances of Scorpio class is better than its parent class, which is basically, let's say, a normal, basic kind of SUV car, right? So yeah, so you want to compare between them. So you want to compare between the parent class and any one of the subclass. But I can do that, or let's say different subclasses. So I can do this comparison between the cars only, right? As we have already talked, we cannot compare between helicopters and cars. So if you want to implement this kind of feature that object was not able to provide us with, the object type, class object type was not able to provide us with, we will see that happening now, that how can we do it with generics. So this lecture, we will learn that. Okay, so anyway, so let us at first go to this code over here and see what we can do. So here in the comment we have said that linked list object L will not work because generics and collections are not covariant. So this is something that we are learning new. What do we mean by covariant? So first see this print list method. Coming back to our code, so we know that this our print list method was basically what it was doing. It was trying to print the values of the list that we have created in this code, and we are passing the two linked list within the print list method. Now, since we are passing ticket list and date list to different linked list, different in the sense they are both linked list class references, but both of them are of different types. They are working with different types of data. So we are passing them in the same method, right? So the parameter of that method should also be a generic type, because basically you are accepting two different types of linked lists. Now, ticket list and date list are both at the end of the day linked list, right? Now they are linked list of what? Different types. What are the types? Just a ticket type and date type. Now in Java, we know any type is a subtype of object class. And since ticket list and date list at the end of the day are just two types, right? Two lists of different types. I can store ticket list and date list into an object reference. Right? So we are not worried about here about some subtype, supertype relation or anything specific that I want. I just want a container to put the ticket list and date list. So simply asking the question, can I have a list prepared and put into any random list of any random type, right? Can I store it inside an object type list? So I have a array list, let's say, or linked list of object type. Let's say O equal to new linked list object, right? Let's say we have something like this. Oh, sorry. Yeah. So we have a linked list like this. Now another linked list. Can I put the ticket list within this linked list? Oh, that's what the question is. Now essentially I can put a ticket type of object within the normal object class object, right? So let's say if I have an object class instance called obj, inside that I can put your t1 or t2 or anything, right? T1, let's say. So this is not an error, correct? This is working, okay. So I can also do that with any other type instance, which is date type instance also, right? So this is also not an error, as you can see. Or I can also just write a number over here, right? So this is also not an error. Why? Because this number is internally getting converted into what? It is not internally a integer, not an int. Correct? And we know that capital I integer is basically a class, the class representation of normal primitive integer. So this is also right. So you can store an integer class type within the object class type. So you can store date type, integer type, string type, ticket type, whatever is there in the object type. So if that is so, then I should also be, let us do a little bit change. I can have an object array over here, obj, correct? And inside that, can I store, let's say, array of integers? No problem. Okay. So I can store integers inside an inside an object instance. I can store an integer value inside an object instance. I can also store sorry, this is comma. I can also store integer array inside an object array instance. Sorry, object array reference. Correct. Okay. So let's take another example. Let's say can I store, since this is an array, I will store ticket type objects within this array. So new ticket. Let's say any string. Right. Another, let's say, right. So this is also correct. No compile error is given, so it is also working. So if I can, so in any object type reference variable, I can store an integer or any custom defined class integer or any primitive class type or any custom defined class type instances. And accordingly, inside an array of object, we can store an array of integer or array of string or array of any custom class type of instances. Right. So if that is so, if a ticket type and date type and int type and string type are able to be stored inside a normal object reference, and an array of ticket, an array of date, array of strings, array of integer can be stored inside an array of object, then I should also be able to store a list of a list of string, a list of ticket or list of date inside a list of object. Correct. So let us do that. We have already created a list here on line number 127. So let us just simply write, make a little bit change over here. Let's say I just mention over here a ticket type initialization. So see, it's not working. Or integer initialization. Then also it is not working. What is the error? Because it is saying incompatible ties, linked list integer cannot be converted to linked list object. But array integer was able to be converted into array object. Right? But what is happening over here? So now this is the thing where generics actually put you, this is happening only because of your generic behavior, because here the linked list is basically a generic type class, these angular brackets, right? So that means in the linked list definition you have used generics, which is true. We have used generics or linked list, generics within our linked list class definition, correct? So whenever you are working with generics, this is something which happens is generics do not allow the, let's say it doesn't allow what we call as covariance. So generics are not covariant. Now what does this mean? What does covariance mean? Covariance mean that just the thing that we just saw, right? So covariance mean if you have a type, a particular type is a subtype of another type, right? Let's say A is a subtype of B, then array of A is also a subtype of array of B. So this property is what we call covariance, right? So if you have a subtype supertype relation between two objects, then also you have subtype supertype relation between any different let's say data structure of that object, right? Or let's say implementation of that object. So like that's why we said that if you have a super subtype relation between between two different types, then the array of those types are also related by super and subtype relationship inheritance if those types or if those features allow covariance property, right? But generics do not allow covariance property. So in that case, an array of object is a super type of array of integer or array of ticket or array of date, but a list of object is not a super type of a list of integer, list of ticket, list of date. Okay, and not only list, any kind of any places, any kind of features where you are using generics, they are not allowing you covariance property. Okay, so even though the individual instances are related by sub super type relationship, when we use them in any feature where generic is given, so in that case, that feature corresponding to that type will not show the super subtype relationship. Fine. Okay. Now since we have discussed this, coming back to our method. So since now we want to print it, we cannot write over here linked list O. Right? Sorry, not O, linked list object. So this object, linked list object, will not be able to capture either ticket list or date list. And the reason for that is we have just seen both ticket list and date list are lists of ticket and date. Although ticket and date are subtype of object, but list of ticket and list of date are not subtype of list of object. So therefore we cannot write over here linked list object. It will not work. Okay, so now we have this linked list T and we have a L as the parameter. And we have defined a normal generic type, and in this case we are using the same concept. Now we have already discussed that how a generic method is defined, so we are doing that only, but here it is very useful to us because here the method is a static type method. Now what happens if we make the method static? See, if the method is static, correct, if the method is static, then that means it is not associated with the objects of the class. Now if a method which is not associated with the object of the class, it is not bothered about the class generic type, correct, because what happens, you define the class generic type. So let's say in this class the linked list class, you have this generic T, and where were you defining the type of this generic? The type of the generic was only resolved within the main method when you are creating an object of that linked list, right? So here, so you are creating an object ticket list and date list, and there that's where you define the ticket and date are the types of the object that you are creating. So this T got referenced over here, right? Sorry, T got resolved over here. But so that means whenever you are instantiating, that is the place where that generic type is getting defined. Now static methods are not dealing with instantiation, right? They are properties of the class, they are not properties of instances. So since they are not associated with instances of the class, so that means they will also not have this binding towards the type which is defined during the object creation for that class. So static methods, if I defined inside a generic class also, there is no concept of overshadowing or things like that. Okay, so because for static methods that initial T which is for the class doesn't apply itself, right? So you have to define extra T, which is basically you have to define an explicit generic method within the class. Got it? So that's why we use here public static T, void print list, and linked list TL, right? So this type is T. Okay, so this is what we call a generic method in a useful scenario. And what it is doing is it is printing the objects of the linked list. Same, not much different. This is basically the same code that we have already seen in our previous coding week 4 coding walkthrough session. I will not explain this. So the only thing over here is that we are in order to accept both the date list and the ticket list, that is that any generic type, we are using this line ticket linked list TL, so that this T can accept any generic value. So it is therefore accepting both date list and ticket list, and it can also accept any list of any different type. Okay, but one beautiful point to observe over here is this generic, in this case of the function definition, this print list function is not used internally for some good purpose, right? Because like let's say in our previous linked list class example, we are using the T multiple places inside the class definition. So here T is used, right? So here T is used, insert, in all the places you can see T is used, here your multiple places T is used. So this T was used, but in this example, as we can see, the T were defined over here and used, this is the parameter over here, and then it is not used internally inside the class definition. So if that is the case, if it is not used, so rather than using T, but I need this passing feature, right? I need this feature of, I need this line which will allow me to pass any data type of list being passed into the print list method, date type list, link ticket type list, any kind of type of list. So I need this generic behavior, but this T is kind of not used, and that's why still we are writing. So is there anything that we can do about it? So yeah, we can do with this is we can use something what we call a wildcard or a question mark. So this only states that I will accept anything that comes to me which is of a linked list class type. So I am not worried about linked list of string, linked list of persons, linked list of employees, linked list of float, linked list of double, whatever it is, I will accept. Okay. So this is where this is something which you use when you are not again using the T type inside the method implementation. So this is what we call wildcard. Okay, fine. One little extra fun work, so not fun, simple work. So what we will ask is, you have this system. So what we are doing in this print list method is something, we are just simply printing the object of the, the returned object that we have, which is basically your generic type object of ticket list and date list, which are basically your ticket and date objects. So basically here we have these 4 objects, T1, T2, D1, D2, and we are trying to print these objects over here by retrieving them from the list after they have been inserted into the list inside main. So we are trying to print them, right? Now the problem with this is, let us run the code and see. Yeah. So you have this ticket at the rate, date, date, and then 4 hash codes. So what is happening over here is, since we are just printing the object, they are returning just the class of that particular instance along with a hashing value, which is basically depends upon multiple features of data that which are present inside that particular instance. So, but this is not what we wanted, right? We wanted something like this, where these values will be printed, right? So in order to do that, we have to call some method, because println will simply, println of object will simply print the pattern which is internally defined by Java, and that's why it is coming like that. Later in some point, not in some point, later some point of time, we will also learn something called overloading your toString operation. So there are some other operations as well, overloading some methods. So when we do that, we will understand that we can set this system.out.println of any object to whatever the way we want that object to be printed, and not the custom way which we just saw on the terminal. So that also we'll learn later. Anyways, so if you want to now we want to change the code to somehow print all those details in a proper manner, and not just this object hash code and class name. So how can we do about it? Let us see the classes ticket and date. As you can see, we have a get value method, correct? So these are printing the values. All I want is to call the get value method by having the object of this corresponding classes. So object we have that interface get next method, right? So get next will return with the object. Okay, so here I have this get next, we have the object, but problem is this object is of object type, right? Object type. Now if it is of object type, by the way, can I store it as a generic type? Same problem, we cannot store it as a generic type, right? Because again, I do not know in the linked list L which it is a generic type class, I know, but inside this L what value is in what position I do not know. So what I need to do in order to call that method is, we need to somehow typecast this O into the appropriate form, into the appropriate class form, and then call the respective method for printing the value, right? But how can I know that, which at what point of the while loop which object is being brought? Or let's say, since there is a method definition, I don't know that inside this L whether it is date list L or ticket list L. If this L corresponds to ticket list, then the objects will be of ticket type. If this corresponds to date list, then the object will be of date type. So I don't know what to do. While I'm generically writing the code, I don't know whether it is at what point it will be date type or what time it will be some other type. So if that is so, then I cannot do the typecasting properly, because I do not know. Explicit typecasting I cannot do. So what to do? What is the solution? So what we will do is, we'll create an interface, let's say printable. So I have an interface printable, and then inside this printable, whenever you see that there are issues with type and you cannot access the methods because you don't know what type it is at runtime. So whenever this type problem at runtime occurs, always the solution is most of the time use an interface and use a common method which is defined inside the interface, and that will take help of method overriding at runtime. And when the instance is resolved at runtime, according to method overriding, the appropriate version of the method will be called. So this is a very powerful tool, and as we can see, we are using it multiple times. So just do it once again. Now I will have this get value method over here, void get value defined over here, and that's it. Now I have this interface printable, and I have to do this implements printable. Date also implements printable. Fine. And now once we have the object O, what to do over here? So you see that, as I told, that we do not know which, when I'm generically writing this function, I don't know whether the date list is in concern or whether the other type of list is in concern. So I have to write some generic code. So rather than typecasting it to date or or any other class type, so let's typecast it to the super type, which is basically your printable type. Now see, this is the benefit. If I didn't have this printable interface, I don't know which type is being given as parameter at what iteration, at in which call. So that's why I won't be able to do typecasting. So printable O, and then I'm doing dot get value method call, and that's it. So this, once it is converted into the printable reference type, the get value will be called of that corresponding class whose object is there actually inside O, but this whether what object is there inside O will only be resolved at runtime, and that's when this overriding will be done. And method overriding once done, it will call the appropriate get value version. Right, so now let us run the code and check. So now you see that the ticket ID is these two values and today's date is these are the two values which are given. This is what we wanted and we have achieved it. Okay, so this is all about your this part of the code. Fine. So let's move to the next part. As we said that we will now compare. As we said that generics provide us with this restricted generic behavior. I mean, it provides us with generic compatibility, but within the generic behavior of different types, it also allows us to put constraints. So now let us see the practical one such example of it. As we see that in this lecture, I think it is lecture 3 of week 5, we say that we will learn something called, as we already discussed, the bounded wildcards. Now in this bounded wildcards, we are able to put an extend limit on the wildcard values. And that's how we will say that, okay, I will accept any type which is a subtype of shape or subtype of any given super type that I'm specifically mentioning, right? So over here you can see that question mark extend shape means I will accept any linked list of any type, but only constraint is that type should be subtype of shape type, right? So anyway, so now let's get into it. The question is asking you that you have a circle, square, rectangle all extending a shape class, right? And all the classes will have a method called draw, and we will override the method. Now what will this draw all method do? This draw all method, as discussed in the slide, will basically print call the draw function by using the object reference of the the object reference that it has got from the by traversing the linked list. So again we are working on the linked list itself. So on our generic linked list we will have a linked list of different shape type objects, and by traversing that linked list we will retrieve those objects, and later on by using the iterator we will basically take each object and call the draw method corresponding to that object. So this is what we want to do, and draw method will do some stuff. So how do we implement this method? So what are the constraints while implementing this draw all method within the while working with this linked list class is that we want this only to be done for the shapes type. As in our previous discussion, as we saw that I will only compare between super type car class and subtype of car classes, and I will compare between super type of helicopter class and subtype of helicopter classes. I will not compare between these two different categories. So that was a constraint that we were able to put by discussing by using the techniques that we just discussed a little earlier, right? But here similar kind of thing is there. Here we are not wanting to allow the ticket type or the date type to be sent as parameter to the draw method. So draw method will only accept parameters which are a linked list of the shape class or linked list of any class which is a subtype of shape class. So if you want to achieve this, how can we define the draw method? So how can we define the draw method? So we will define public static as it is given in the slide as well, void draw all. Now, so here things we will provide it according to the generic behavior. So extends shape, and so only constraint is it should be a shape type and not ticket or any random linked list object type. So let's say L, right? Linked list. Yeah. So now the method is kind of ready. We will add the definition within it. Fine. So now we have defined this method. Now let's start the body. So which is object O, and then it is basically the same iterator code. Right, iterable I get iterator till here it is same. Right. Yeah. Now after this I will call o.draw. But you see that if I call this draw method, it is giving me an error that this draw is not defined for object type. It will give, because the reason is O is an object type reference, and draw is a method which is defined inside the shape and the shape subclasses. So in order to do this, again we have to do some typecasting. So let's do the typecasting at first. And over here we will write the shape type. Now it is fine, right? And then it will take use of the overriding, and then it will call the proper version of the draw method in the respective class. Now let us visit these classes that we have already defined. Let us as of now minimize this main method. So these are just simple class definitions, so I will not discuss them in detail. Just we have a shape class and three classes: circle, square and rectangle, extending them, right? Extending the shape class. Each of these classes have their corresponding behavior, like radius, data member like radius, shape has, square has a side, rectangle has length and width, like that. And and they have constructors. Each of them has constructor to assign them with the values, and a draw method which we have to basically override. And this draw method is something which is kind of calculating the area and printing the area for each of the shapes. So this is how the structure looks. And so here we are defining this draw all method. Now the thing is, now let us go over here and create some objects, and let's use this particular this method. So let's say I want to create a linked list of, right, a shape type, linked list of let's say shape only, or let's make it a linked list of circle at first. Circle, ticket list. And again, then let us make a linked list of square, right, and square list. Rectangle list. Fine. So we have created these new three lists, and now we have to put objects into them, right? Okay, so let's make it like this: circle list dot insert, and insert this new data. We are basically passing double type values, I think. Yeah, so double R, so double type values. We'll pass some double values, let's say 23.57, right? Oh, sorry, I'm just not inserting, right? Wait, sorry. New circle, and within the circle I will value 23.7, right? Okay, so we have inserted one object into the circle list. Let's keep it as one object only. You know that anyway we are able to print the different values inside our linked list, so that is okay. So what is happening? It's type, okay, insert new square, and let's say 10 in the square size, right? And rectangle list dot insert and new rectangle, let's say 10.0 comma 20.0. Okay, so we have created all these three lists with one element each, and now let us call the draw all method for each of them. So draw, oh, we have this, yeah, draw all method, square list followed by draw all method, circle list, and sorry, and again draw all method for rectangle list. Okay, so we have called the draw all methods. Now let us see. So this will only extending shape type acceptance method, and let's say if I try to do it other way around, so let's say I call this ticket list to be passed inside draw all. Let us see what happens. So if you let draw all, and inside this if I write ticket list, you see there is an error, and it will say that this is not a type of shape subtype. It is not a shape subtype. That's why we are not allowing you to be passed inside the draw all method. So you can see, let us see what it says. It's an incompatible type. Linked list ticket cannot be converted to linked list extend shape. Got it? So this is how you can implement constraints inside generic behavior as well. So anyways, so I'm not allowing. So this kind of that comparison of, it will not allow comparison between helicopter and car, but it will certainly allow comparison between different helicopters and car categories. Okay. So nothing else to do. Let's run the code and see what happens. Yeah, so square of area 100, circle of area some value, rectangle of area 200, ticket ID, and these are for the other things. So you can see these are correspondingly calling the correct draw method according to the overriding. So this is working. So you have one method draw all, which is accepting all kinds of lists, but only thing is it is constrained under that it is a shape type of shape class, and that is printing any kind of all the different implementation of the draw method by using the method overriding of inheritance. And similarly here we are using a linked list L, which is again accepting any type of linked list to iterate through it and print the values by using a interface which is able to, therefore we are able to typecast it into a printable type, and that's why we are able to call the get value method. Otherwise we would not be able to call the get value method, because we do not know at compile time that at one runtime what will be the instance type within the let's say list, right? So what is the instance type returned by the iterator at line number 150? I don't know what is the type of O. So in order to use the get value method, we must typecast it into a common type which will be able to use the method overriding feature. So only you can do that with interface or super class. So since there was no super concept or super class in the previous example, so that's why we went with the interface side of it. Great. So we have learned about bounded wildcard. Right? So it a wildcard which is bounded by super type. This is also allowed with the other way around. So we have also something called let's say something super shape. So in place of extends, I can write super shape, and which essentially is the other the reverse of what extend means. So if I write this question mark extend shape, means I will accept any class which is a subclass of shape. Whereas if I write question mark super shape, that would mean I will accept any class which is a super class of shape. So I can write it as the same thing. I can write it as super circle. Now the thing is, you see the rectangle and shape, rectangle and yeah, just a second. You see the rectangle and square are getting into error. As this is what I was saying. This is happening because we use the super type of circle. Right? So any class which is super class of circle. Now rectangle and squares are not super class of circle, but certainly if we had a shape class over here. So let's say circle list. Let's change it a little bit. Let's say that we have a shape list. Right? Now shape is not an interface, it is a proper class, so that's why it is something for which we can create instance. Right? Shape, let's say shape list, done. Shape list. Now let's say we insert a value inside the shape list method as well. So shape list dot insert, let's say new shape, and yeah, so inserted one value. Okay, and let's say then I say draw all, and yeah, that shape list, so it is working perfectly. It is not showing any trouble, right? It is working. So this is what super means. It will accept the circle list. It will accept any super class of circle, which is shape list. So question mark extend circle means sorry, not extend, question mark super circle means any type which will be a super type of circle. So that takes circle itself and any super type of circle. So therefore these two are not showing any error, but rectangle and square are showing error. So basically these are all the things that we have discussed about bounded types, bounded wildcard types. Okay, yeah. Now we will discuss one more thing over here, and that is the reflection concept. Now, what is this reflect thing? We will not do it in very much detailed way, because this is something you can just play around with and see. There is not much conceptual part to discuss over here. Some features are provided, and this is you can basically do some introspection work, which is called reification, as sir has discussed in the lectures. So this is mainly done by the programmer side, those who are kind of doing a troubleshooting task or debugging task. So it is mainly used in debugging purposes, troubleshooting purposes, performance analysis purposes. So basically you have written a code and you are kind of, before putting it into production, you want to see that how internally things are working and is there some starvation happening anywhere, things like that. So basically you are doing an analysis of the code which is already in a running state to see how fast the code is working, to see how securely the code is working. Let's say at some point of time a particular object should not be visible in the form that it is visible, things like that. If you want to monitor when the program is in a running state, and then you can use this reflection concept and the reflect library to actually refer to the internal parts of the code and kind of pick it up and manipulate it, customize it, and see what happens, and then you can work upon it. So yeah, so what we will basically do is, what we have in order to display a little bit applications of this reflection, we have defined inside this utility shape class, right, main method, in which I have a random number generation from 0 to 30. So that is put inside a choice variable, and then this if else ladder will basically check if the choice is an even number. So then I will put a circle type object inside S. If the number is a odd number but it is divisible by 5, then I will put a square type object inside S, and otherwise I will put a rectangle type object inside S. So these are the three types of classes that we are defined under this class, under this Java file. We are putting it into S, and then what I'm doing is basically I'm checking for because at this point at line number 14 I do not know that which class is particularly there inside S, right? I know one of them would be there, but I don't know which one. So since I do not know which class is there, now I will use the reflection framework to actually find out some details regarding the instance type. And so we will do this system.out.println using the get class method. The get class will return me the class, and then this is the according to this object area will come later, just after some time. So after that, once we get the class, we can see print the class and see what class is it inside S. But there is something what we can do which is much more interesting than that using the get class. So get class is returning me a class type reference. Right now, what is this class? This, as Sir has discussed this also in the lecture, that is basically nothing but a class for, whenever a class is loaded in Java, for each of those classes an object is maintained of a class type class. So that is another class basically, which is kind of an internal, it is defined, and the object of that class, that the name of that class is class. So the object of that class are basically representations of the other classes that are defined in Java. So therefore we define this class. The C object refers to the class of S type of the S object, right? S object it belongs to whichever class, that class is returned to the C object, and since this C object is itself an object of class type, so therefore as it basically coincides with the definition that we just discussed, that this class type is basically such a class which the object of which class are basically nothing but instances which represent each class which are loaded in Java. Anyway, so once I get this class C, I can use the get fields method to get the fields and get methods method to call the methods. And then I can, first method obviously, since I'm working with this shape subclasses, all of them have this draw method at least, and no other method as well. So since that the method 0 component will always be there, which is corresponding to the draw method in all of them. And then I can use the invoke function call of methods to basically invoke that particular method on the object of S. Right, because S is the object which is concerned. So this method and fields are all actually belonging to the S object. Now I am trying to go a reverse way around by taking the class of S and then referring back to the objects and methods. So, but they all basically belong to S. So we have to pass S as the parameter inside invoke, and it is according to the syntax that again we have to pass array, simple object array. So we'll pass that, but it's just because of syntax. There is not much to do in this example regarding that. So once we do that, we can just then invoke the method, and we can see the draw method is called once. And yeah, so let's check what happens if I execute this code. So as you can see that it is printing the class rectangle, right? Yeah. So over here, if you see that it is printing first get class, which is rectangle, and then it is printing the method.invoke. So this is the draw method. So draw method in case of rectangle was only what it was doing. In case of rectangle, draw method is printing the area of rectangle, right? In all of them, it is printing the area. But anyways, yeah, it is length into breadth. This draw method is printing the area. So in case of rectangle, in our example, we have assigned the rectangle with value 12 and 6, right? And so therefore the area would be 72. So yeah, rectangle area you get 72. If I run this code again, a random number will be generated, and again there is a chance that I might get a different shape. So let us try that. Again we got rectangle. Yeah, this time we got circle. You see that I have a circle over here, and the area is 314, right? Because here the radius of the circle is given as 10. So pi r square we get 314. So basically this is working fine. We are basically able to invoke the draw method of each of these instances by using the invoke method on the reflection type framework, right? Invoke method of the reflection framework. So you can do this kind of stuff. That is, without the object, we can still get the class name. Without using the object, we can get the class name, we can get the methods, fields, and all those things. Just play around with it. I'm not discussing each of the things discussed in slide. Just write it in this code and you will get the results accordingly. Right? And one important feature along with all of this is the last lecture, which is your type eraser in Java. It is a theoretical concept, as Sir has already discussed. I will not go into any details of it, and not much to do about the coding part of it. So what it happens is basically when you use these generics, so they will be at runtime, they will be converted to the object type, and no further type information is maintained at runtime. And other than that, where bounded generics are used, they will be converted to the uppermost type. So if I write t extends, let's say shape, so all the places where I use t, that will be converted to shape at runtime. Correct. So no further information will be kept. So therefore, if I just define two different array list of string type and let's say another of ticket type, and I check the equality between them, equality between their instances, so it will basically, since the equality of object type happens after the object resolution, an object is resolved only at runtime, and I'm saying that generics, when working with generics, all the type information at runtime is elevated to either object or the super type in case of bounded generics. Right. So therefore, so if I write a string type and a ticket type and find equality between their instances, that whether both of the class of these two instances are same or not, both of the answer will be true because both of their classes will be object type. Right. So you can just check the slides accordingly and understand what it is. I'm not going into the coding part of it. Okay. So fine. Anyways, I hope so. This was helpful for you guys. That was it for week 5 coding session, and hopefully you guys find it helpful. Thank you, everyone.